This is a unit circle. It's all about having a hypotenuse of 1 and finding points from angles. Okay, we're going to fill it out together. We'll start with just doing degrees and radians. There's lots of stuff to fill in. We've kind of already done this together. This is 0 degrees and 0 radians. This is 360 degrees and 2 pi radians. So I also know that this is 180 degrees, or pi radians, over there at that side. Here's 90 degrees, and here's pi over 2 radians. Let me turn that little line into a fraction bar. And down here at the bottom, we talked about this being 270 degrees and 3 pi over 2 radians. Okay, we good so far? Somebody tell me another angle measure that we know.
45.
Yeah.
And the 30.
We really know that this is 30, and this is 45, and this is 60. Those are just our 3 special numbers we're going to be dealing with a lot. 30, 45, and 60. So the question becomes, what are those in radians? How do you know that? Okay, do you know why it's pi over 6 or pi over 4 or pi over 3? Okay, why is it pi over 4?
Because it's 1/4 over there, I guess it's just 1/6.
Yeah, so if this angle here, if this one's pi over 2, which is 90 degrees, if we do half of that, 45 degrees is half of that, that'd be pi over 4. By the same logic, 30 degrees, you know, this angle here, 30 degrees is a third of 90. So a third of pi over 6, or pi over 2 radians is pi over 6. And then why is it pi over 3?
Because it's 2 times 30 degrees.
2 times 30 degrees, or 2 times pi over 6, and 2 pi over 6 is pi over 3. Okay, so if this is 90 and we're adding on, well, it's easy to go from your reference angles. We're going to go back 30 from 180. So this is going back 30 degrees from 180. So this is 150. Going back 45 degrees from 180 is 135. And going back 60 degrees is the same as going forward 30 degrees. This is 120.
There's a little dot thing, isn't that for the degrees?
Yeah, I think that's what they're doing. Thank you. Is that value taken?
Yeah,
Okay. Well, now the whole world knows that it bothers you because the whole world can hear this on the internet.
Wait, but why would you go back each time by 180, go back like what, 45 off 150?
Well, because
You're not going 45.
this was 45 degrees. This one right here was 45 degrees from 0,
Oh, okay.
right?
So
This is the same 45. It's the same triangle.
it's just for one.
It's just going from 180.
Yeah.
You could also do it from 90 if you wanted. It'd be the same thing.
Yeah.
Find these radian measures. Which one's 3 pi over 4, Mac? How'd you do that? How'd you do those ones?
Just
Now you kind of start counting. It's like, if this is 1 pi over 4, and this is 2 pi over 4, and this is 3 pi over 4, and that's 4 pi over 4, so this one's going to be 5 pi over 4. And this one down here at the bottom is 6 pi over 4. So this is going to be 7 pi over 4. And this is 8 pi over 4, which is the same as 2 pi. Just count by your fractions.
Uh,
What's the matter, Cassie? You're going to go through that again?
oh, you're counting just the 45.
Just the 45s.
Okay, that's why I got all.
This whole circle is going to be a lot easier if you do it in groups, do it in patterns. So we counted by pi over 4s. We can also count by pi over 6s. Do this in blue. If this is 0, and then I have 1 pi over 6, and 2 pi over 6, and 3 pi over 6, and 4 pi over 6, and 4 pi over 6 reduces to 2 pi over 3, and then 5 pi over 6, and 6 pi over 6, and 7 pi over 6, and 8 pi over 6 will reduce to 4 pi over 3, 9 pi over 6, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, and 12 pi over 6. 2 circles, or a whole circle 2 pi. I'm not really expecting you to understand this right now, in the sense that you don't really quite get what a radian is yet. You don't really know what a radian is yet, and I don't expect you to because you just saw it a week ago for the first time. It's a weird idea. But now we'll go through and do the degree measures. Those I do expect you to wrap your head around. Do the last 6 degrees on your own. Should be there. Now all that's left is to find these points. Find these points on the outside. Again, we can do the easy ones. This is the point 1, 0. This is a circle with a radius of 1. This is the point 0, 1. This is negative 1, 0. And down at the bottom we have 0, negative. So we have these 9 in-between points to find still. Remember, those 9 in-between points are based on the fact that this 45, 45 right triangle is root 2 over 2, root 2 over 2, and 1. Whereas this 30, 60, 90 triangle is 1/2 and root 3 over 2. So armed with those angles and those distances, all that means is that this distance from here to here is root 2 over 2. Now that I know that, for this 30, 60, 90 right here, this distance down here is root 3 over 2, comma, 1/2.
What was the side measures for the 36?
Is it going to be the same all the way around?
Mm-hmm. It follows a pattern.
It just goes root 3 over 2, 1 over 2, 2 over 2, root 2 over 2, and then 1/2 square root of 3 over 2, and just root 2 over 2 again.
Well, these are going to reflect these points here. I'll come over here.
Okay.
So this is going to be negative 1 over 2 root 3 over 2 because the x-coordinate is negative, the y-coordinate is positive. Okay, the x-coordinate's negative, the y-coordinate's positive. Okay, fill out the rest of your circle. And I'm not expecting you to do this quickly or easily. You know, it takes some thinking. Fill out the rest of your circle. Now you're going to tack that onto your homework. So all you're going to do is also fill out your unit circle. Which I've done 9/10 of.
I do.
Cassie, what's your question?
When you're going from 180 to 210, would you then go back to where you started when it first? Negative 1/2. The y's negative, not the x.
Yeah, now they're both going to be negative.
Yeah.
That's going to be negative and negative. It'll be the same points as this one.
This one, okay. Oh.
So its reference angle is this one,
I got that.
right? That's the reference angle.
That's what I said.
Oh, yeah.
I'm talking about when
Root 2 over 2.
Negative.
Negative root 2 over 2.